What's up, guys? Today we're going to be talking about a few different things. We're talking about the breakdown of red blood cells. We're talking about blood, kind of what's in the blood. We're also talking about the clotting cascade, one of my favorites. So first, let's talk about what's in the blood. Okay, so let's say we have a vial of blood. We're going to have there, right there. Okay. So let me grab a few different colors here. So we have our vial of blood. Vial of blood's made out of a few different things, okay? So first up here, you have what's called your plasma. Plasma is going to take up about 55% of blood volume. Now, plasma, it has kind of a few different things in it. Pretty much what it has, your main molecules in your plasma, so you're going to have albumin. We've already talked about albumin a little bit. It contributes to your hydrostatic pressure. I guess your osmotic pressure and your hydrostatic pressure. You have albumin. You also have something called globulin. Gamma globulins are antibodies that help us fight infection. Okay, so all of that is part of your plasma. Then down here, you have what's called your formed element. And that's going to include both your red blood cells, okay, as well as this thin little layer up here. It's called the buffy layer. And that is white blood cells. So that is the composition of the blood. Now we're going to focus on your red blood cells and basically how we break those down. So we're not going to talk a ton about how they're formed, erythropoiesis. We're going to be talking about hematopoiesis, the breakdown of them. Okay, so let me just make a little red blood cell there. Yeah, let's put that and here. Okay, so hemoglobin. Hemoglobin is made out of 4 chains. I've only drawn one. This is called heme. Basically, hemoglobin would, it's like a long, it's kind of tubes. This is terrible drawing, but it's basically tubes. It kind of looks like your small intestine. But basically, what happens is this circle in the middle of hemoglobin is called heme. There's one heme per chain, so there's 4 hemes. And basically, what it has is heme can fit 1 oxygen and 1 iron on it. Okay, so heme, the iron is actually going to give blood, the red blood cells, the red color. And then the iron, if there's iron on it, it's going to make it a light red. It's called, or if there's oxygen on it, it's going to make it light red. It's called oxyhemoglobin. If there's no oxygen, it's called deoxyhemoglobin. Okay. Now we're going to break it down. So first, we have our hemoglobin. Okay. Now, hemoglobin is made out of 2 parts. Okay, so you have your heme. Draw a line over here. So heme. And then your globin part, your globin. Your globin part is going to get broken down into amino acids, which are then going to get recycled and used to make more red blood cells. Your heme is going to get broken down into a few different parts. So you have your iron, which is actually going to go onto transferrin and enter the blood again. Now you have the rest of your heme part is going to go and it's going to get broken down. Perfect. You can still see. It's going to get broken down into something called, let me change colors because this actually has a color. It's going to get turned into something called biliverdin. So now we're in the liver. Basically what's going to happen in the spleen, in the liver, is they have like this mesh kind of like a catacomb sort of thing, like a net. And normally red blood cells can fit through if they kind of twist and squeeze a little bit. Once they're old, they're not as flexible. They get stuck, macrophages come, and macrophages do all this. So we have our biliverdin. Biliverdin is going to get transformed into something called unconjugated bilirubin. You might have heard of bilirubin before. So unconjugated bilirubin, we're now in the liver, okay? So in the liver, unconjugated bilirubin is going to get conjugated. When it's conjugated, it might be hard to believe, but we're going to call it conjugated bilirubin. Okay, remember this is happening in the liver, right here. Okay, conjugated bilirubin is going to pass through the gallbladder. And when it does, it's going to get transformed. It's actually going to pick up something called glucuronic acid. Glucuronic acid is going to surround the conjugated bilirubin and turn it into bile. Bile is going to make its way down to the intestine. Now in the intestine you got lots of bacteria. Now bacteria is actually going to eat the glucuronic acid because it's a sugar. They're going to eat it off of your conjugated bilirubin, and when they do, that turns it into something called urobilinogen. Now urobilinogen can do two things. It can get transformed. Part of it can go back into the blood. Part of it can come over here and become something called stercobilin. Stercobilin is brown. And that's actually going to go out through the feces, which is why your feces is brown. It can also go down here to the kidneys, and it's going to become something called yellow urobilin. And that is going to get peed out, which is why your pee is yellow. Okay, so now if we look at someone with jaundice, what jaundice is a collection of bilirubin in the body. So it can actually happen if you have high conjugated bilirubin or high unconjugated bilirubin. The way to tell is to do a blood test, okay? If someone has jaundice and you do a blood test and they have high unconjugated bilirubin, it means there's a liver failure because they can't turn it into conjugated bilirubin. If they have high conjugated bilirubin, it means you have a problem with your gallbladder, your bile duct, because you can't change it into bile, okay? So that is the breakdown of blood all the way to your urobilin. Now we're gonna do the clotting cascade and kind of how hemostasis. Hemostasis is basically just making sure blood is okay. You can do a few things when you have a cut. First thing you can do is vasoconstriction. This is just going to isolate the affected area. It's great for